The plan for this lesson is to discuss datasets and data types. The big goal is understanding types of data and their structures, which is part of the pre-processing step for data analysis. First, we will review types of datasets that many of us interact with, then discuss data objects and data types such as nominal, binary, and numerics. On a very high level, we are going to discuss 4 categories of datasets: relational records and data matrices, graphs and networks, ordered data, and spatial imaging and multimedia. Here's an example of a relational or structured data. The word relational comes from the entity relationship model from the data management. Every concept or object is represented with its data in one table. Here's a small data set: a person's object and a car's object. And as you can see, the attributes are stored in these tables. Matrices are another example of structured data consisting of rows and columns and their associated values stored inside these cells. As you can see, there are empty cells, which means there are no value representing the rows and columns combinations, which is totally fine. Another thing, this particular matrix is storing numeric data types. But in general, we can store any data type. It can be textual or something else. Transactional data consists of an ID and several items that appeared in that transaction. For example, think about a transaction as one visit to the grocery store where someone has bought a number of items. Document data looks like a matrix where the rows represent the documents and the columns represent the words that appeared in these documents. The value stored in the cells is going to represent the frequency of this word in this document. Graphs consist of nodes and edges, and these edges can be directed or undirected, weighted or unweighted, and depending on the application, we're going to have a different network structure. Ordered data is unique in the sense that the order of the data points is meaningful. One example is temporal datasets that represent information that changes over time. Think about the stock market, the weather, the rainfall. Another temporal example is video. More examples of ordered data is genetic sequences. So these sequences encode complex proteins. But it's important also to remember that not all ordered data needs to be temporal. It depends on whether the time dimension is meaningful here or not. Graphic and medical imaging represent complex information that we want to further analyze in many applications like medical diagnosis and agriculture. Dimensionality refers to the number of features or attributes in a dataset. In complex models, think about generative AI, the dimensions can vary from hundreds to millions and sometimes billions. So high dimensionality is going to increase the complexity and the computations of the analysis. Sparsity indicates the presence of many zeros or null values in the dataset. Working with high dimensional and sparse data can be challenging. Resolution, or the level of detail, refers to the granularity of the data. So high resolution is going to provide more detail, but it may also introduce noise. Lower resolution is straightforward, but it's going to miss patterns. Distribution describes how data points are spread across the feature space. Understanding a data object's representation and structure is important for data analysis. So let's break down the concept. A data object represents an entity that consists of several attributes or features. We are interested in analyzing these properties or characteristics. Here are a few examples. Customers, store items, sales are all features in a sales database. Similarly, patients and treatments are features in a medical database. The illustration is a snapshot from the New York Times COVID-19 colleges data. The data objects, sometimes called samples, examples, instances, data points, tuples. Most likely in the data mining and machine learning communities, they refer to data objects as examples. Attributes are also called features, dimensions, or variables. In this example, there are two attributes. The first one specifies a school name, and the second one is a Boolean type attribute that specifies whether the school is a K-8 or not. So, why do attribute types matter? Remember, the data pre-processing step involves computations such as computing similarities and distances between the attributes. So, choosing the appropriate metric has a lot to do with the attribute data type. We are going to study 4 types, which are nominal, ordinal, interval, and ratio. Nominal attributes are simply names of categories. Order here does not matter. Some of the examples: marital status, hair color, and school names. Binary attributes are nominal attributes with 2 possible values: yes or no, true or false, positive or negative, and can be symmetric when both outcomes have the same significance. For example, when studying trees in a forest, whether a tree is evergreen or deciduous, both outcomes carry the same significance. On the other hand, asymmetric attributes, one outcome is way important than the other. Think about a positive medical test. A positive medical test requires more follow-ups than a negative test. An ordinal attribute is an attribute in which the order of the values is significant. However, the magnitude of significance between 2 successive values is unknown. Examples are drink sizes, letter grades, and rankings. At this point, we have studied nominal, binary, and ordinal attributes, which are all qualitative attributes that describe the feature, but it doesn't give a numeric weight. Numeric attributes are quantitative because they measure a quantity. These attributes can be interval scaled or ratio scaled. What does that mean? In the case of interval scaled attributes, each interval has a specific meaning or interpretation. For example, temperature is interval scaled attributes because each interval on the scale is going to have its own interpretation. This happens as a consequence of not having a true 0 point. So we can't say 80 Fahrenheit is twice as warm as 40, right? But we can describe individual intervals on the scale. Something like 40 to 50 is cool, 50 to 60 is mild, and anything above 90 is hot. On the other hand, ratio-scaled attributes have a true 0, which means the division operation is defined and 10 years of experience is as twice as long, 5 years of experience. Also, numeric attributes can be discrete or continuous. A discrete attribute has a finite set of values, zip codes, professions, and words in documents. One important note is that binary attributes are also a special case of numeric discrete attributes. Finally, continuous attributes are defined over a continuous range of values, typically real numbers, and some of the examples are temperature, height, and weight. In summary, data attribute types are nominal, binary, ordinal, interval scaled, and ratio scaled, and there are many types of data sets like numerical, text, and graph.